GCP Platform and Cloud Engineering Part 25. This episode has 23 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. How would you design cloud governance for naming, tagging, and policy controls? Here's a strong way to approach it. Define naming standards for projects, resources, environments, regions, and ownership. Require tags or labels for owner, cost center, application, environment, data classification, and compliance. Enforce critical controls using org policies, policy as code, CI checks, and cloud-native policy tools. Governance should improve visibility and reduce risk, not become only documentation. Nice. Let's continue. Question 2. Scenario. Many cloud resources have no owner or cost tags. What would you do? Here's a strong way to approach it. Create an inventory. Identify high-cost and high-risk resources. Map ownership using logs, billing data, repositories, and deployment pipelines. Then enforce tagging on new resources. For existing resources, run a remediation campaign with deadlines. Add policy checks in Terraform and CI or CD to prevent recurrence. Great. Moving on. Question 3. How do you implement least privilege IAM in GCP and Azure? Here's a strong way to approach it. Start with role-based access by persona and workload. Avoid broad roles such as owner. Use service accounts or managed identities, separate duties, and apply access at the narrowest practical scope. Review permissions regularly. Use groups, audit logs, conditional access where appropriate, and break glass access for emergencies. For workloads, prefer short-lived identity federation over long-lived keys. Alright, next question. Question 4. Scenario. A production service account has excessive permissions. How would you remediate safely? Here's a strong way to approach it. First, identify actual permission usage from audit logs and service behavior. Create a least privilege replacement role or binding. Test in lower environments. Roll out gradually. Monitor errors, and remove broad access after validation. Communicate the change and keep rollback steps ready. Let's keep going. Question 5. How do you embed DevSecOps controls into CI or CD? Here's a strong way to approach it. Add dependency scanning, secret scanning, SAST, container image scanning, IAC scanning, license checks, SBOM generation, policy checks, and deployment gates. Fail builds for high-severity issues based on agreed policy, but provide clear remediation guidance. Security should shift left while still supporting fast delivery. On to the next one. Question 6. Scenario. A secret is found in a Git repository. What immediate and long-term steps do you take? Here's a strong way to approach it. Revoke and rotate the secret immediately. Assess exposure through logs and repository access. Remove it from current code and history where required, and notify security if needed. Long-term, add secret scanning, pre-commit hooks, secure secret managers, developer training, and least privilege credentials with short lifetimes. Good. Here's another one. Question 7. How do you conduct a cloud security review? Here's a strong way to approach it. Review IAM, network exposure, encryption, secret handling, logging, vulnerability posture, backup, data classification, policy compliance, and incident response readiness. Use automated tools plus manual architecture review and threat modeling. Produce prioritized findings with owners, timelines, and risk context. Nice. Let's continue. Question 8. Scenario. A vulnerability scan blocks a production release. How would you respond? Here's a strong way to approach it. Assess severity, exploitability, exposure, compensating controls, and business impact. If risk is high, block or delay release and remediate. If the finding is lower risk or false positive, document the exception, approval, expiry, and mitigation. A senior answer balances security, delivery, and customer impact. Great. Moving on. Question 9. How do you design observability for distributed systems? Here's a strong way to approach it. Use metrics, logs, traces, events, and synthetic checks tied to user journeys, standardized dashboards, correlation IDs, structured logging, read or use metrics, slow burn rate alerts, and runbooks. Observability should help teams detect, debug, and explain production behavior quickly. Alright, next question. Question 10. Scenario. Users report slowness but infrastructure dashboards look normal. What would you check? Here's a strong way to approach it. Check application latency percentiles, dependency latency, database queries, DNS, load balancer metrics, client-side errors, regional routing, queue depth, thread pools, connection pools, and trace spans. Infrastructure metrics can look healthy while application or dependency behavior is degraded. Let's keep going. Question 11. How would you implement monitoring, logging, and alerting for Kubernetes applications? Here's a strong way to approach it. Collect cluster metrics, node metrics, pod metrics, application metrics, Kubernetes events, container logs, and traces. Alert on slow burn, crash loops, pending pods, resource saturation, deployment failures, and dependency errors. Use dashboards by service and runbooks for common incidents. On to the next one. Question 12. Scenario. Kubernetes pods are restarting after a release. How would you troubleshoot? Here's a strong way to approach it. Check rollout history, pod events, container logs, exit codes, probes, resource limits, config maps, secrets, image version, dependency connectivity, and recent code changes. If customer impact is high, roll back first and continue diagnosis from evidence. Add tests or deployment checks to prevent recurrence. Good. Here's another one. Question 13. How do you design Kubernetes deployment orchestration with Argo CD? Here's a strong way to approach it. Keep manifests, Helm charts, or customize overlays in Git. Argo CD reconciles desired state to clusters with application health checks, sync waves, environment overlays, RBAC, and deployment approvals. Use progressive delivery tools if needed for Canary or Blue-Green. Git should provide auditability and rollback. Nice. Let's continue. Question 14. Scenario. A Kubernetes deployment succeeds but traffic still goes to the old version. What would you check? Here's a strong way to approach it. Check service selectors, labels, endpoint slices, ingress configuration, load balancer health checks, service mesh routing, DNS cache, Argo CD state, and whether pods are ready. Also confirm the new version is actually serving and not failing readiness checks. Great. Moving on. Question 15. How would you design Kubernetes clusters for high availability? Here's a strong way to approach it. Use regional or multi-zone clusters, multiple node pools, pod anti-affinity, topology spread constraints, pod disruption budgets, readiness probes, autoscaling, backups for stateful components, and controlled upgrades. Avoid single points of failure in ingress, DNS, storage, and external dependencies. Alright, next question. Question 16. Scenario. A GKE or AKS node upgrade is blocked. What would you investigate? Here's a strong way to approach it. Check pod disruption budgets, pods without controllers, local storage, daemon sets, insufficient capacity, maintenance windows, node pool surge settings, cluster autoscaler limits, and workloads that cannot be evicted. Plan upgrades with capacity buffers and application disruption budgets. Let's keep going. Question 17. How do you support both Azure and GCP cloud services as a cloud engineer? Here's a strong way to approach it. Focus on common cloud engineering principles: IAM, networking, compute, Kubernetes, storage, logging, security, and automation. Understand platform-specific services and identity models, but standardize through Terraform modules, CI or CD patterns, tagging, observability, and governance. Avoid assuming both clouds behave identically. On to the next one. Question 18. Scenario. You need to migrate a workload from manual deployment to CI or CD. What is your approach? Here's a strong way to approach it. Document the current release process. Identify risks. Create build artifacts. Automate tests. Define environments. Add deployment scripts or GitOps manifests. Introduce approvals. And perform parallel dry runs. Start with a low-risk service. Prove the pattern. Then scale it as a reusable template. Good. Here's another one. Question 19. How would you build automated runbooks for resilient operations? Here's a strong way to approach it. Start from common incidents and manual operational tasks. Convert diagnosis and remediation steps into scripts, workflows, or self-service actions with safeguards, logging, approvals where needed, and rollback. Runbooks should include symptoms, impact, commands, owners, escalation, and validation steps. Nice. Let's continue. Question 20. Scenario. A runbook fixed an incident once but failed the next time. What would you improve? Here's a strong way to approach it. Review assumptions, missing pre-checks, dependency changes, permissions, input validation, and observability gaps. Add automated tests or simulations for the runbook. Version it, assign ownership, and update it after each incident. Runbooks need lifecycle management like code. Great. Moving on. Question 21. How do you shift left QA, security, and operations into the SDLC? Here's a strong way to approach it. Move testing, security checks, deployment validation, observability requirements, and operational readiness earlier into design and pull requests. Use templates, CI gates, threat modeling, automated tests, runbook requirements, and production readiness checklists. Shift left works best when teams get fast feedback, not only more blockers. Alright, next question. Question 22. Scenario. A team says security check slow delivery. How do you handle it? Here's a strong way to approach it. Measure where delays occur. Tune false positives. Provide clear remediation. Cache scans where safe. Parallel ICI jobs. And define risk-based gates. Keep critical controls mandatory while improving developer experience. The goal is secure delivery with less friction. Let's keep going. Question 23. How would you measure platform perceived performance? Here's a strong way to approach it. Use user-facing metrics such as page load time, API latency percentiles, error rate, availability, synthetic checks, and real user monitoring. Combine these with backend traces and dependency metrics. Perceived performance should be measured from the customer or consumer perspective, not only server CPU. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.